Okay, so we're talking about this. Thank you. Thank you. Talking about the tax function. So, what is the input of the tax function? What is the
taxable income?
Taxable income. Okay, so before we talk about this, we've got to make sure. So, use them there. Taxable income. What's the output? It's the and what's the unit of that? So what's the unit of what that is? Dollars, right? So it's the amount of tax due. I am. Thank you. Okay, so when you see the form of this, just in a broad sense, what do you notice?
Like our point slope.
He said, is it the point slope form? What was the point slope form? Okay, so is it the point slope form? Okay, yeah. So this is the point slope form. Okay, so this is a piecewise linear function. Each piece is linear. So each piece has the point slope form. Okay, so let's break it down. So what about the x minus? All right, so we'll do it here. So the x minus 34,000. What does it mean? X minus 34,000. What does that quantity mean? Christian?
Doesn't that represent like the change in x?
Okay, it's a change in x. Okay, so can you talk about, so somebody else, what about in the context of taxes? Yeah, James.
It's the amount of money earned in the tax bracket above 34,000.
He says the amount of money earned in this tax bracket, in this one.
Going from 34,000 up to the point of x.
What do you think about that? Is that what the change in x is? The amount earned in this tax bracket. Yeah, that's it. Okay, so now I'm going to go switch to red here. So now all of this, somebody new. What does all of that represent? I'll put a circle. David.
That would be amount of taxes owed. You were above 34,000 up to $82,400.
Okay, so you're saying it's an amount of tax owed. Amount of tax owed. So on which amount of money is it the amount of tax owed?
Just on the change of, the amount of income over 34,000.
Right. So whatever you make over 34,000 up to your current income. So X is a changing amount, which your current income in that bracket. It's going to be your tax due, and what can we say that's? How can we represent that? Change in Y, right? Because changes in Y are K delta X. So what is K? How is 0.25 a constant rate of change? Talk to the person next to you. How can you understand 0.25 as a constant rate of change? Okay.
Taxes.
Okay. Volunteer. All right, so we said that that whole amount is the taxes due on the income in this bracket. So anyone can you explain how the 0.25 is a constant rate of change? Aaron?
It's the basic percentage that, within that whole within the range of, within that range of 34,000, it's that amount percentage that, is supposed to be deducted from the 0.25.
Okay, so we want to relate it to our understanding of constant rate of change. So how is it so that's true. What you're saying is absolutely true. But so how can we understand it as the way we've been learning constant rate of change? Chloe.
For the change in x, which is x minus 34,000.
Okay.
Y will change by 0.25 times over.
Okay. All right. So you have this amount of income in that bracket, and so what is the change in y calculating, and what does the 0.25 have to do with it? Yeah. Tell me your name again. Steven.
I quarter every dollar that you earn over 34,000 will take over tax.
Okay. All right. So for every dollar that you earn in that bracket, the tax that you'll pay is 0.25 as much as right. So it's relative size. It's the relative size of what to what.
Change in Y.
But talk about tax. Talk about tax. It's the relative size of what in the tax scenario.
The relative size of tax
Tax.
income to taxes due.
Relative size of taxes, amount of income to taxes due. Is that what it is? It's 0.25, right? So it's a quarter. It's a quarter. So 0.25 would be the relative size of. No, it's the tax due you pay is a quarter of the amount you earn. So it's the relative size of tax due to how much you earn in that bracket, right? For every dollar in that bracket. Okay, and then what's the point of this? So why do we add what, Ryan? Yeah.
So, I don't know if I'm saying it right, but that's the point of why when you left off the previous bracket.
Okay.
started a new bracket.
And what does it mean? So yeah, right, exactly.
It's the starting point of taxes at that 34,000
And why do we add it to this?
to start off your next margin from that point.
Okay.
Whatever the next point is.
What is the whole, why addition? What is it adding together is calculating what for us? Yeah, James.
The cumulative total taxes for each bracket that you earn.
Okay, so this will get you the total tax that you have to pay on which dollars? All the dollars that you've made up to 34,000, because this is the ones what in this current bracket. That's all the taxes you owe in this current bracket. This then gives you all the taxes you owed what in the previous bracket for all the 34,000 you made before. You see? Okay, so yeah, so it's the same thing. We got change in X, which is our taxable income in the current bracket, times the constant rate, which gives you the tax due on the money in the current bracket, plus the old Y, which is the tax you owed before. So you can see how this is a perfect example of our point slope formula. The new Y is the new value of Y is the old Y plus the change in Y. Okay, any questions on that review? And all right, so let's. So remember, we talked about we can show constant rate of change in two different ways. So over on the right, we're showing constant rate of change, and over on the left, we're showing constant rate of change. It's two different views of the same thing. So let's ask some last questions here. Where should you look in this animation to see Sarah's taxable income growing? Where should you look in this animation? Is this Connor here? Where would you look to see the taxable income growing here? The right graph. What about the right graph? The X values on the right graph. What do you think? Jonathan, agree with that?
Well, you can look at the X values on those graphs.
Okay, X values on both graphs. Is it Alina or Elena? Either one. Elaine, okay. So there's one said on the right graph, one said on both graphs, the x values show the taxable income.
I think I agree with both.
Yeah, so in both cases, our x-axis is the income growing, and you can see this. See the dark bar increasing in length. That's showing the taxable income growing. Okay, and so in both cases, in both graphs, it's the quantity on the x-axis. Okay, where should you look to see the marginal tax rate for the current value of her taxable income? Where should you look to see? What's that? What about the left graph?
Because that's the only one that shows the marginal tax rate.
But what about the left graph are you looking at to see the rate?
The y-axis and the constant lines that are at certain points.
Yeah, go ahead.
You could also look at the slope of each of the segments on the right graph as well.
Okay. All right. So the more, yes, that's true. So the more direct would be what Melody said. Just look at the left graph, right? It's because it's telling you the y values are telling you what the tax rate for the current. So where would you look to see the amount of tax that she owes for the current value of her taxable income? Peter.
You would look at the right graph, the value of the point.
What? So the value of the point. What? Can you be more specific?
Right graph.
I'm sorry.
You would look at the value of the point on the right graph.
Okay. So.
The point that the x and y coordinate.
All right. So what? Yeah. What about that point that would you look at to see?
You would see how much she owes. Like you would multiply the tax rate by the income she has at that point.
Okay. So, right here.
Yeah.
So what would you, if you just wanted a quick estimation of her tax due, what would you look at?
I guess it would be the left graph. You would take the taxable income and multiply it by the.
Now, if you just wanted to get a quick estimate without doing any calculations, how would you get the amount of tax due for this current amount of her income?
The y-axis of the right graph.
Okay. And where would I stop along the y-axis?
Where the point is.
Okay. So, right. So it's the y value of that point, right? So you said the value of the point. So it's specifically the y value of the point will give you the tax due. All right. And what do we mean by current value of her income? What does that mean? The current value of her income? Isn't it always changing? The income always increasing as time goes by. So what do we mean by the current value?
The value at a specific point in time.
Yeah, it's kind of like we have to pause time, right? So it's like we come along and we say, we just pause time here like this. And so what's the current value if we pause time? What's the current value of her taxable income?
5,000.
Of her taxable income? Yeah, something like 28,000, right? Sorry, that gets in the way. But it's something like 28,000, right around here. Right around here is the current value of our taxable income. So we got to pause time, right? We got to pause time and we say, okay, we pause time. This is how much money she's made up to this point in the year. Okay, what does a point on the right-hand graph represent? And the next question is, what does the point on the left-hand graph represent? So I want you to talk about that one for 30 seconds. What does a point on the right-hand graph represent? What does a point on the left-hand graph represent? Go.
On the right, next one is still taxable income, but it's not how much you use the rate. 500 per year instead of the actual. So like the second background would be more yeah.
Okay, we'll start with left. Brent, talk to me about a point on the left-hand graph.
It's the function of tax rate.
Shoot. What is it now?
Like the function, it gives you the tax rate for the taxable income.
Okay, good. So it's two pieces of information, right? When you have a point, It's two pieces of information. The x coordinate is,
The taxable income,
so maybe we estimate it's about 28,000. And then
then it's a tax rate at 28,000, which is like 0.15.
0.15. Okay, so that's the tax rate on what? So if for this point, what is that the tax rate on specifically? What's that?
The tax rate on the 28,000
So it's the tax rate on the first $28,000 that you earn. Is that right?
on that margin.
It's the tax rate for this whole thing. That's what 28.0.15 means, that point.
So it's a tax rate for 18,000?
Tax rate for 18,000. But we're talking about what that point represents. So that value relative to that point, it doesn't represent something for $20,000 or $12,000. Does that make sense? So what does that 0.15 represent?
Would it be the tax rate of $28K?
Right, exactly. It's the tax rate on the current dollar that you're making. You see, it's the tax rate on the current dollar that you're making. Okay, Sterling, you're up. So what does the point on the right graph represent?
That's the amount of tax due for 28,000.
And can we estimate that? Something like 3,000, something like that?
Yeah.
Right, again, two pieces of information. Yeah, and it just keeps getting worse and worse. Were you gonna say something? It sounded like you were. No, you're good. Okay, so yeah, so this point over here for a taxable income, it shows the taxable income and the corresponding what? So what tax? Tax on what? Let's be very specific about what that number represents relative to the $28,000 that you made.
It's the total, it's the tax rate of 28,000 plus the tax growth plus.
So you're saying it's all the taxes on all that money earned so far. She said all the taxes due on all the money, all 28,000 that you've earned that far.
Yes.
Yes. So this is what we're going to call the accumulated total accumulated tax due. Okay, so the rate is just for the next dollar or the previous dollar, right? But this point now, it represents the sum total of all the accumulated tax due for the first $28,000. Make sense? Okay, cool. Okay, so we're going to skip these. Okay, in what way does tax due accumulate, and how is it reflected in the graphs? So, in what way does Sarah's tax due accumulate? 30 seconds, go, see what's going on. So, in what way do the taxes accumulate?
So for like first, so around $8,000, there's like this tax rate that's on that. So then past that is like so tax rate. And that's the stuff that changes now and different ones.
Okay, so you're saying like every single time tax your tax rate that is like different rate changes.
Yeah, because like on the first $8,000 she makes, she's taxed it, and then past that, she's taxed a higher amount, and then past
Okay, let's hear what you guys thought.
$8,000, it's even more.
Janae, what do you think?
Like that together is 10,000.
Her tax rate accumulates, so, for the first, so her taxes accumulate at a certain rate to a certain point,
Okay,
and then accumulate at a different rate to a different point.
okay.
So on.
All right, so they accumulate. So how about just within? That's exactly right. They accumulate up to a certain point at a certain rate, and then the rate changes, and it continues to accumulate at a different rate. That's absolutely right. But within say within the second bracket. How do taxes accumulate, say within a bracket? What's that? Constantly, okay. All right, so have you seen snow before? Snow? Yeah. So it starts to snow. So for those of us who have been out of Arizona, all right, it starts to snow, and you look out your window, it starts to snow. You close your eyes, and you open your eyes, and there's a foot of snow, right? And then you close your eyes and open your eyes, and there's 2 feet of snow, right? And then you close your eyes and open your eyes, and boom, there's 10 feet of snow on the ground. Is this how it works? No, this is not how it works. How does it work? How does snow accumulate? Gradually, right? So you clean your apartment and you come home later that night and there's an inch of dust everywhere in your apartment. Is that right? Is that how it works? No, right? So how does dust accumulate? How does dust accumulate?
Over time.
Over time, that's true. But how over time? What's that? Yeah, little bits at a time, right? Little bits at a time. That's how things accumulate. Okay? So the tax due is accumulating a little bit at a time. A little bit at a time. So for instance, so come over here. So say I'm right here, and I'm gonna make $10 more. I'm gonna make $10 more. How can I represent that? I made $10 more. Yeah, delta x, right? So if delta x is 10. And so then what happened to when I made $10 more, what happened to my tax due?
It goes up
How much does it go up?
15%.
Okay, so I have a corresponding what? Change in y. And how could we calculate that change in y? Everybody should know this.
0.15 times the change in x.
Right. 0.15 is our constant rate, and so to get changes in y are always 0.15 times change in x. And in this case, that would be?
10.
How much did your tax, for making those next $10, how much did your tax go up? Oh, please don't use a calculator for that. It's times 10. It's times 10.
I can't do it.
Oh, okay. All right. How much does it go up? $1?
No,
$1.50, right? $1.50. Okay. So for us, so how does your tax due accumulate over time? As you make little bits of money, what happens? Your tax accumulates bit by bit by bit. So for say if you want to do by $10, in this bracket, for every $10 that you make, your tax goes up a little bit, right? It goes up, right? And that's really easy to calculate if we have constant rate of change, you see? Okay, so here we are at the tax due on, looks like I'm at like 43,000, okay? So the tax due on 43,000. How can we represent that in this idea that your income accumulates bit by bit by bit? How can you represent that tax due on 43,000 as an accumulated amount bit by bit? Anyone? Could we mathematically represent that?
An average?
No.
Is this where we use the piecewise function?
So think about bits like this. This is how much this tax due goes up for, say, an increase of $10 earned. So how can we represent the total tax due on 43,000 kind of in this context as it accumulates?
Is it the 0.15 times 43,000, or x minus 43,000?
Okay, but in terms of how do things accumulate? They accumulate bit by bit by bit. So first $10 that you make, how much tax do you owe?
The very first $10?
Yeah,
Just $1.
$1. How can we represent that dollar?
Changes
Delta y, call it delta y1, okay? Then next $10 that you make. How much are you gonna owe? How can you represent it?
Delta y2.
And how does things accumulate? So
Delta y1 plus delta y2.
yeah, so then we're gonna add the next little amount that we owe, right?
Yeah.
And then the third $10 that we make. All the way up to. So now let's make these $1 each, okay? How about so this is the first dollar that you make, second dollar that you make, third dollar. So all the way up to. How many things are we going to add together? 43,000 little amounts of tax due. Okay? 43,000 little amounts of tax due sum up to, accumulate up to how much total that you owe in taxes. And how can we and we come along here and we've got say the $518th that we make. How can you calculate that tax due on the $518th that you make? Should all know that. So how can I calculate the tax due on the $518th? Peter?
You add all the delta y's before 518.
Okay, we're going to add all those together to get the amount due on that dollar. You disagree? What will you do? 0.1 times delta x, which we're saying was 1, right? $1 earned. You see? So every one of those little bits of tax accumulated, we can use constant rate of change reasoning to calculate how much taxes owed. And then what do we do to get the total amount accumulated? We add them up. Add up all the little bits. This is calculus, okay? This is calculus.
Does that still work even though the percentage rate changes?
All right, so now we come over here and we want to calculate delta y for the 28,186th that we made. How would you do it? 0.15 times delta x. Because now your rate, for these bits, the rate changed. So you have a different constant rate. But you're still going to use the same constant rate reasoning to calculate the amount due for that little bit. Yeah, make sense?
So you don't have to keep jumping from like function to function for this like method?
I'm not following you.
Like, so you wouldn't have to, because that's 2186. So wouldn't the tax rate change? From like the first $100,000 to the first $10,000?
Yeah, so now we're here. So now it's right about where I drew this, right? So if I make one more dollar here, how much do my taxes go up? We're in this bracket now, so 0.15 delta x.
Oh,
So we're just calculating the change of those points, not the total. I follow. I don't know the question.
Okay.
I'm just trying to clarify. So if we were paying the delta y up to the 20,000, would it be the sum of delta y1, delta y2 up to the 10,000 mark before you would apply the sum?
So the first 10,000 of these delta y's, we're going to use 0.1 times delta x.
I guess that's what I'm asking.
Yeah.
If you were to write it all the way out, then it would be delta y all the way up.
But
to
once you get to the 10,000th and first dollar, that's going to be the first delta y where we switch to this one, right?
Okay, and then you could sum up this way.
You can sum up.
Well, because you're saying delta y, the 518 equals the 1% or the 0.10 times x,
Yeah.
and that's up to the dollar. Then we switch to the 20,000 area, and that's delta y of equals 0.15 times x. If you need to find the total of that bit by bit by bit by bit, would you just sum up?
Every single one. Count from 1 to 43,000.
So, but would it be like 1 to whatever the first piece of the piecewise function breaks off at plus like the remaining, or is that like a different concept? That's what I was confused about.
There's going to be 43,000 delta y's that we add together. The first 10,000 of them, we're going to use this this constant rate of change to get the little bit of tax due. Starting on the 10,001st delta y, we're going to start using this rate.
Okay, so the first rate at the 0.10 times x equals, the answer is something. and then you find the next amount that's 0.15.
But we could stop. So there's nothing special about 10,000. We could stop anywhere. So we can, to find the tax due on the first $715, we add together the first 715 delta Ys. To find the tax due on the first $25,000, we add together the first 25,000 delta Ys. So it's just, the only thing about this point is just the rate changes. Your constant rate changes, but you just keep adding delta Ys all the way.
No, I understand.
Yeah.
I understand that.
Is it better?
I'm just saying, if you were doing this longhand, trying to find out taxes owed on the 20,186, you would first have to find the sum of all of the delta Ys between the 0 and 10,000 mark. Then you would have to find the taxes between the 10,000 mark and the 30,000 mark.
Because of the different rates of change.
Because of the different rates of change, and then you could sum
The
up
first 10,000 delta Ys will use 0.1. Starting at the 10,001st delta Y, it will be 0.5 up to this one. It'll just change. You should have 10,000 delta Ys, and then the next one, it'll change to this rate.
So you don't really have to separate the two.
You don't have to separate it. Yeah, it's like you're trying to separate it, and it's just dollar by dollar. How much tax do you owe? Dollar by dollar by dollar. Keep adding it up. That's all it is. And then there's a certain point where the rate changes, and you just keep adding dollar by dollar. Yeah. Okay. All right. So let's have you see if you can. Play. All right. So what were our amounts here? 10,000. So don't look at any notes or anything. This is 10,000. And what was this? 34,000. And finally, so we'll just. I think this is showing up to 70,000. Okay, so can you write the rate function? And can you write, without cheating, without looking at something else, can you write the tax function? So we should be able to do this. So what does this function do? You can plug in any taxable income from 0 to 70,000, and it'll tell you what your tax rate is for that taxable income. What does this function do? You plug in any taxable income from 0 to 70,000, and it'll tell you what your tax due is. So without peeking at, we've seen it before, but so can you reproduce these two functions? Work together.
Is it starting at which one?
Oh, yeah.
It's not starting at 0. When one x is 0, y is 1. Plus.
And then you can use the right sum.
There's no.
Oh, yes. Because
Yeah. There's no change.
so plus B, right? Yeah. And then the next one.
So it's experiencing 10,000.
And then is the next one 1, 2, 5.
It's negative 1, 1, 5.
After this.
Oh, yeah, he's 0.25.
Because I'm doing this T 1,000. Is that
Or you can see it in this. Because it's
one
saying-
seven?
Yeah, I think that's right where it's
This is
as much in dollars and a half.
Okay, so we know we had to break this up in pieces, right? In that first taxable income from 0 to 10,000, what would be our rule for the tax rate? What should we get out of this function if we plugged, say, x equals 5,000 in or x equals 7,000? What should come out? Yeah.
0.1.
She just wants 0.1. Alexander likes it. That's it. No matter what x value we put in from 0 to 10,000, 0.1 should come out of the function, should be the tax rate. All right, and then similarly, and then, what is it? Is it 28 or no? Is it?
Yeah, it looks like 28.
It's like 28.
I think the next one's 28. I think this one's 0.25. Is that right? Yeah, I'm pretty sure the next one's 0.28. Okay, so then what about the taxes due?
First piece is, isn't it 0.1x if x is greater than 0 or
From
less
zero-
than or equal to 10,000?
0 to 10,000. 0.01x, right? So it's going to be right there, 0.01x. And then,
1.5 x minus 10,000.
Good.
Tax on 10,000.
that's right. So we have the amount in the next bracket, x minus 10,000, times the rate gives us the amount of tax in this bracket plus
T of
t of
10,000.
10,000, that's right. And that's for this second bracket, etc. And then next rate,
1.25 times x minus 34,000 plus t of 34,000.
and that's from there. Okay, so how do things accumulate? Little piece by piece by piece, bit by bit by bit. Okay? So in addition to, so that you have two things for homework. You're sending me, I'm going to send an email out Sunday. You'd reply to that with your file for your piecewise generator. Please don't change the subject line. Don't write me a message in that email. You need to message me, start a new email. And then there's also I posted another written portion to hand it in class. Okay? Have a good weekend. If you want some old homework, I got some old homework.
Oh, there are red places.
Thank you. Today's?
Yes.
Yeah, I'll put you.
Alright,
What's that? No, I will though.